Hi all, let's start the session in few minutes. So let us start our gate marathon session, today's session. So first let's discuss what is rank of a matrix. Okay. So for this subtopic of rank of matrix, we will be discussing some previous year questions today. Okay. So just introduce what is rank, then we will go to the questions only. Okay. So rank of matrix is nothing but it's defined as maximum number of linearly independent rows or columns. Okay. So we have two methods, more than two methods. We will discuss two methods to determine the rank. Okay. The first one is row echelon form or REF form. So we need to convert a matrix into row echelon form using elementary row operations. Then after that, the number of non-zero rows in the REF row echelon form is the rank. Okay, we can do the problems and understand the REF method better. Then the next method is using determinants. Okay, previous session on marathon session we have discussed some questions on the subtopic determinants. Okay, so rank is nothing but the order of highest non-zero square submatrix. Okay, or we can say minor of order R. Let's consider a 3 by 3 matrix. Okay, in 3 by 3 we have 9 elements. Okay, so the highest order minor in a 3 by 3 matrix is nothing but 3. Okay, we have 3 rows and 3 columns. That's the highest order minor. So first we need to check the determinant of that highest order minor is 0 or not. If it is 0, the rank is less than 3. So the next step is we need to calculate minor of order 2. Okay, that is we need to calculate all 2 by 2 elements of that matrix and determine the determinants. And if any one of that having a non-zero determinant value of minor of order 2, then the rank will be 2. Okay, we can do the problems and understand the rank better. So just introducing what is rank here. So now let's jump into previous year questions. Okay, from this topic. Okay, this is the first problem. If you are watching, you can do along this. Okay, so first problem. The rank of m by n matrix where m less than n cannot be more than. Okay, this is the question. The rank of a m by n matrix where m is less than n cannot be more than. Okay, let's assume this is that m by n matrix. What does it mean? It is having how many rows? 1, 2, up to m rows and how many columns? 1, 2, up to n columns. and we have it's already given that m is less than n. Okay, so number of rows m is less than n. So this rank is defined on what we have said. Using determinant of a minor we can calculate the rank. So in order to calculate determinant we need a square matrix. Okay, so we have given m is less than n. So the maximum order of the square matrix that we can get from this m by n matrix is nothing but m by m. Okay, since m is less than n, the maximum order of the square matrix that we can get from this m by n matrix is nothing but m by m. Okay, so if this m by m matrix is giving a minor of order m with the determinant not equal to 0, okay, then the order or the rank of this matrix will become m. Okay, so the highest possible rank is nothing but m here. Okay, since m is less than n. I think the concept is clear for you. So let's conclude this. The answer for this first question is option A. So let's check anyone answered. Okay, okay, so we will be moving on to next question. Okay, so this is the second question. The rank of matrix is, okay, we have given a matrix here. A 3 by 3 matrix is given and we need to calculate the rank of this matrix. Okay, so what's the first step? First step is considering the largest minor of this matrix. Okay, what is the largest minor? The matrix itself is the largest minor. Okay, so we need to calculate the determinant of this matrix. So since this first row is having two zeros here, we can calculate determinant along this row. Okay, so we get m3, that is considering the minor of order 3, the determinant equal to minus 3 is, okay, minus 3. So this is from first row and third column. So minus 1 raised to 4 will be 1. So 1 into minus 3 into 10. We need to calculate the determinant of this part. This is 9. This is 9. So 9 minus 9, which is equal to 0. Okay. So the minor of order 3 is giving determinant value 0. So what's the next step? Now we need to calculate minor of order 2. That is considering 2 rows and 2 columns. Okay. If I consider this element, okay, then 0 into 3 minus 0 into 9, which is giving a determinant value of 0 for this minor. Okay. If I consider this one, 0 into 5 is 0, minus of 3 into minus 3, which is giving determinant value as 9. Okay, which is a non-zero value. So we are getting a non-zero value for minor of order 2 here. So the rank of matrix is nothing but 2. Okay, so I think the concept is clear for all of you. Okay, so let's jump into next question. Yeah, okay, let's go to the third question. If for a matrix the rank equals both the number of rows and columns, then the matrix is called. Okay, if for a matrix the rank equals both number of rows and columns, then the matrix is called. Okay, so let's assume a matrix here. Okay, let's assume a matrix of order m by n. Then what the question says, rank equals both number of rows and columns. Okay, if rank equals both number of rows and columns, we can take this as m by m. That's it's a square matrix, right? Since the rank equals both number of rows and columns, the matrix we are considering is nothing but a square matrix. Okay, then the question is matrix is called. We have four options: non-singular, singular, transpose, and minor. Okay, so according to the definition of rank of a matrix, which is equal to number of rows and columns. So we are considering a square matrix where number of rows is equal to number of columns, and rank is also equal to number of rows here, okay, or number of columns here. So that means the determinant, let's say this is A, and determinant of A is a non-zero value, okay, of order m. If determinant of A is a non-zero value of order m, then we can say the rank of this matrix A is m. Okay, rank of A equal to m. Okay, so if rank of A is equal to the number of rows or number of columns, then the determinant of A is a non-zero value according to the definition of the rank of matrix. Okay, so if determinant is non-zero, we call that matrix a non-singular one. Okay, so the answer for this question is nothing but non-singular. Okay, so if any doubt, you can comment. So let's jump to next question. Okay, so the fourth question we are discussing here, the rank of following n plus 1 by n plus 1 matrix where A is a real number is. Okay, we need to calculate rank of this matrix. Okay, where it is given that this is a n plus 1 by n plus 1 matrix. Okay, so here A is given as a real number. What we need to do here is that just observe these rows. Okay, the first row we can see 1a square up to a raised to n. When we look at the second row, which is also 1a square a raised to n, or the last row 1a square up to a raised to n. Okay, so what we can do here is that we can do some elementary operations. Okay, that is, we can write r2 as r2 minus r1, r3 as R3 minus R1 up to Rn plus 1 minus R1. Okay. When we do these elementary operations on this matrix, what is happening here? R2 is R2 minus R1. Since R2 and R1 line both are same, when I do R2 minus R1, this becomes 0. This also becomes 0. This becomes 0. This becomes 0. Okay. Similarly, up to this n plus 1th row, this becomes 0. All these other rows except this first row, all this becomes 0. Okay. 0. So ultimately, this is reduced into a row echelon form, or the only non-zero row existing will be this first row only. Okay. So what is the maximum order of minor that we can get from this one row? Okay. That is nothing but 1 here. Okay. So if we do these operations, we will be getting the reduced echelon form or the equivalent matrix as this row only, and all other row will become 0. So the rank of this matrix is nothing but 1 here. Okay. So the answer, the final answer to this problem is 1. Okay. So let's jump into our next question here. Yeah. So here we need to calculate the rank of matrix. Okay. It's a direct question. So what's the step we need to do? First, we consider M4, that is fourth order minor, that is the matrix itself, the complete matrix itself. So let's consider this row, okay, as this is okay. Before doing that, let's just look at this matrix, and if there is any possibility to reduce any rows, or some simplifications can be done or not. Okay, so let's look at that. Consider this first row. This is 1, 4, 8, and 7. Here we can see 3, 12, 24. Okay, so this multiplied by this multiplied by this multiplied by 3 is giving here 3, 12, and 24. So I can do one operation, elementary operation, that is R4 equal to R4 minus 3R1. Okay, if I do this, if I do this, this matrix becomes 1487, 1487. This remains the same. 0030, 0030, then 4231, 4231, 312, 24, 2 will become 000, and 2 minus 21 is minus 90. Okay. This is the equivalent matrix here. Okay. So here, now I am calculating the minor of order 4 using this row. Okay. So first I need to find the determinant using this element. So 3 into determinant equal to 3 into this is the second row and third column. So we have a minus 1 raised to 5 here into, now remove this and this. So the final determinant we need to calculate is 1, 4, 7, 4, 2, 1, 0, 0, minus 90. Okay. Since we have done that row operation, we get this row. Okay. So we can calculate the determinant much more easily. So which is equal to minus 1 into 3 into, then minus 19 is which row and which column? Third row and third column. Okay. 1, 2, third row and third column. So minus 1 raised to 6 is 1. So minus 19 remains the same. Then we need to remove this. So need to calculate this. This is 2 minus 8, that is minus 6. Okay. So where we don't need to multiply this, we can get a non-zero value here. So determinant value is not equal to 0. A non-zero value is we got a non-zero value for a minor of order 4 here. Okay. So we haven't done a minor of 3, 2 or 1 here. Even in the order of 4 itself, we are getting a non-zero value. So the rank of this matrix is nothing but 4 here. Okay. So the final answer to the question is 4 here. Okay. So I think all of you got the same answer. Okay. So now let's jump into next question. Okay. Sixth question. Here the question remains the same. Okay. We need to calculate the rank of the matrix. Since we are discussing the subject of rank, we are uh, discussing these problems which comes under the topic rank here. Okay. So here let's look at the rows here. Okay. The first row, second row and third row. Okay, when we look at this third row, we can see that 1 plus 3 is 4, 2 plus 4 is 6, 3 plus 5 is 8. So we can do one operation like R3 equal to R3 minus R1 plus R2. Okay, so if we do this, the equivalent matrix become, the first row remains the same, second row also remains the same, third row becomes 4 minus 3 plus 1, that is 0. 6 minus 4 plus 2, that is 0. 8 minus 5 plus 8, that is also 0. So, okay. So if we get one row completely 0, the determinant of the order 3 will be always 0. Okay. So the rank of this matrix will be always less than 3. That's we are sure. Okay. Now consider some second order minus here. Okay. If I consider this one, 3 into 0 minus 0 into 4 is 0. If I consider this one, 4 into 0 minus 5 into 0 is 0. So don't conclude on that. Let's consider another one. Okay, here if I consider this one, 1 into 4 minus 2 into 3, that is 4 minus 6 is minus 2. So for order of 2, we are getting a determinant non-zero value. So the rank of the matrix for this problem is option C, 2. Okay, since we are getting a non-zero value for this minor. Okay, minor of order 2 is giving a non-zero determinant value. So the answer to this question is nothing but 2. Okay, yes. So we are jumping to next question. Okay, this is very simple question. These are all gate question, previous year gate questions. Okay, so all of you should answer this correctly. Okay, these are simple topics from engineering mathematics gate questions. Okay, so let's go through this. Okay, the rank of the matrices. Okay, so direct question. If I consider this 2 by 2 matrix, I'm getting the determinant value 0. So the only option is taking a minor of order 1 here. Okay, so this is giving a non-zero value. So the order is nothing but 1 here. So the answer is very direct. Okay, option C is the answer. So eighth question. So here we need to find the rank of this matrix. Okay, when we look at this matrix, look at this first row. This is 1 1 1. Third row is also 1 1 1. So we can remove this to 0. So R3 is R3 minus R1. So which is giving the matrix equivalent matrix as 1 1 1, 1 minus 1 0 and 0 0 0. Okay, then we can do some. Okay, since this row is 0, this row is 0, the order is the rank of this matrix will be less than 3 for sure. Now look at the minor of order 2 here. Okay, let's look at this one itself. Okay, this is 1 into minus 1, that is minus 1, minus 1 into 1, that is 1. That is, if I consider this minor of 1 1 1 minus 1, which is equal to minus 1 minus 1, that is minus 2. So this is giving a non-zero value. Okay, since a minor of order 2 is giving a non-zero value, the rank of this matrix is nothing but 2 here. Okay, so the answer to the question is option C, 2. Okay, now let's jump into next question. Okay, ninth question. Let A equal to Aij, where I is greater than or equal to 1 and j is less than or equal to n, with n greater than or equal to 3 and Aij equal to I into j. Then the rank of A is. This is the question. Okay, you can try this one. This is a good question. How to solve this? Okay, in the comment, what is the rank of matrix? Okay, uh, in this marathon live session, the initially I have discussed what is rank of matrix here. Okay, you can refer to that. Let me explain from the previous example. Okay, here, okay, rank of matrix is nothing but first we need to consider all these matrix together. Okay, so calculate the determinant. If determinant is non-zero, the order is 3 or the rank is 3 here. Okay, since we are considering a 3 by 3 matrix here. If the determinant of this matrix is 0, we need to calculate the subset of 2 by 2 square matrices like this submatrix, then this submatrix, this submatrix, this submatrix, like that. If any of the submatrix is giving a non-zero value of determinant, then the rank is 2 here. Okay, so that's how the rank is defined. So let's get back into the ninth question here. Okay, so anyone got answer for this question? Okay, so let's solve this question. Okay, okay. A equal to, let's first understand how we can write that matrix A here. Okay, A11 is the first element, then A12 is the second element. Okay, up to A1n. Why A1n here? Since j is less than or equal to n, we are writing up to n here. Okay, so I in Aij, I represent number of rows and j represent the column. Okay, since j is less than or equal to n, the maximum number of columns here 1, 2 up to n columns. Okay, we have given I is greater than 1, that is the number of row is greater than or equal to 1. That's given in the question. So we can write next column, next row as A21, A22 up to A2n. Okay. Then how many rows we can write? Okay, that's the next thing. Okay. So the maximum number of columns here is n. Okay. So we can write maximum number of rows up to n here. Since we are discussing rank here, okay? So n1, a, n2, a, n, n. Okay. Since we are discussing rank here, maximum number of columns is n columns. Okay. So even if we consider more than n rows here, that doesn't count to rank here because we have to consider square matrix find determinant for finding the rank of a matrix. So since the maximum number of columns is n, we can consider up to n rows. That's why the last term is an1, an2 up to an. Now it is given that aij equal to I into j. So a11 s, since aij equal to I into j, a11 is nothing but 1 into 1, that is 1. Okay. A12 is 1 into 2, that is 2 here. Similarly, A1n is 1 into n, that is n here. Okay. Similar way, A21 is 2 here, A22 is 4 here. Okay. A2n is 2n here. Okay. Okay. Similarly, we can replace this line n 2n up to nn. Okay. Now consider this whole matrix and let's understand each row here. Okay. This is second row. This is nth row. Okay. So what we can do here? We can do some elementary operations. Like this is R2. R2 is nothing but 2 times this R1. Like if I multiply 2 to all these elements, it is equal to the second row. And consider this nth row. Okay. In nth row, if I multiply n with each row and subtract that value from this nth row, we will be getting 0 here. Okay. So what we can say here is except this first row, all other rows can be written as a combination of this first row, or let me write like this. Okay. If I do operations like R2 given R2 minus 2R1. Similarly, R3 is given as R3 minus 3R1 up to Rn is equal to Rn minus nR1. We will get all the rows except the row 1, we will be getting 0. Okay, this will become 0. Similarly, all other rows will become 0. This becomes 0, this becomes 0, all becomes 0. So it is a reduced row echelon form, or only one independent row exists in this matrix. So the only square matrix or the square matrix or the minor of order 1 can be taken from this one row here. So the rank of this matrix will become 1 here. Okay. So the final answer to the question is nothing but option B 1 here. Okay. I think all of you got the idea here. So let's jump into the final question here. Okay. This is the today's final question. Okay. The rank of a 5 by 6 matrix Q is 4. Okay. The rank of a 5 by 6 matrix Q is 4. Then which of the following statement is correct? Okay. This is the question. We have four statements. Q transpose into Q is Q will be invertible. Q into Q transpose will be invertible. Then option B is Q will have four linearly independent rows and five linearly independent columns. Q will have four linearly independent rows and four linearly independent columns. Okay. So in the given question, it is given that it's a 5 by 6 matrix Q. Okay, 5 by 6. 5 rows and 6 columns. And the rank of this matrix is 4. What does it mean? According to the definition of rank, rank is nothing but the total number of linearly independent rows or columns, okay, which remains the same. Okay, so from the definition of the rank itself, since the rank is 4, the matrix Q will be having 4 linearly independent rows since rank is 4. Also, it is having 4 linearly independent columns. So, from the definition of the rank itself, we can answer this question. The option A is the correct answer for this question. Answer comes from the definition of the rank itself. Okay. So, option A is correct. The option B, you will have four linearly independent rows. This is correct. And five linearly independent columns. This is not correct. Okay. If it is having five linearly independent columns, then rank would have been 5 here. Okay. So what's the maximum number of linearly independent rows or columns is the rank of that matrix. So it's already given that 4 is the rank of the matrix. So the matrix will be having four linearly independent rows or four linearly independent columns here. So today's marathon session ends here. So in the next session, I will be covering more problems on eigenvalues, and I will select some good questions from that topic, and I will be following this pattern in the coming sessions also. We'll select one subtopic and bring some previous year questions and solve here. So, okay, thank you for listening, and please subscribe, and you will be getting more marathon like sessions in the coming days here. So, Shah Fahim, thank you for the comment again. And I explained what is rank in the introduction level. So I think I will be more focused on problem and discuss theory in between. Mm, actually, not. Mm, should I introduce the topic, then do the questions, or I should focus more on questions? That's a dilemma. Mm, okay, I will be doing sessions and depends upon what comment section or chat says. I will be improving later on. So, thank you. Okay, bye. Good day to all. Okay. Thank you.